In this video, we're going to do some exam style questions on curve sketching. In question number 1, we're told the graph of y equals f of x for x between 0 and 6 is shown below. I've put it to the right here so we can have a larger view. The graph touches the y-axis at the point 0, -1, which is just here, and crosses the x-axis at the point 5, 0, which is just here. In part A, we're asked to state the coordinates of the point where the curve y equals -5f of x touches the y-axis. We can either see this as two transformations, a reflection in the x-axis, which is -f of x, and then a stretched scale factor of 5 in the y direction, or we could simply now multiply the y coordinates by -5. So if we did that, we would simply have -5 multiplied now by -1. That is going to give me +5. Therefore, now we're going to touch the y-axis at the point 0, +5. If you reflected this in the x-axis, you would get this point going from -1 to +1, so it'd have 0, +1, and then 5f of x multiplies the y coordinates by 5, or puts a scale factor stretch of 5 on in the y direction, which would take us to the point now where y is 5. So 0, 5, any way you look at it. In part B, we're told the curve y equals f of ax crosses the x-axis at the point 12.5, 0. We're asked to find the value of a. F of ax is a 1/a scale factor stretch in the x direction. There are lots of different approaches again with this particular question. If we consider now that the coordinate here, or the x coordinate, is 5, if we think now 12.5 divided by 5 is going to give us 2.5, or 5/2. Therefore, what I can say now is that the value of a is going to be the reciprocal of this. So what we're going to have then is now 2/5. If we divide now the x coordinate 5 by 2/5, that's essentially what we're doing when we have f of x. We're dividing the x coordinate by a. If I divide 5 by 2/5, I'm going to end up with 12.5. So that is one approach. Alternatively, if you wanted, you could say 1/a multiplied by 5 is going to be equal to 12.5, and simply rearrange that equation. So we could say 1/a is going to be equal to 12.5/5. So from here we could see now that 1/a is going to be equal to 2.5. Therefore, from this, a is going to be equal to 1/2.5, which is going to give us now the 2/5, or if you like, 0.4 as a decimal. So that's what we end up with. Either way, I prefer this way, but it's entirely up to you. In part C, we're asked to write down the number of solutions to the equation f of x plus 3 is equal to 0. F of x plus 3 is now simply a translation of 3 units in the positive y direction. So what we'll do is lift this graph up by 3. So it's asking me, if I lifted the graph up by 3, how many solutions would this have to the equation f of x plus 3 have? All I'm going to do to visualize this is actually put this line here. So that's going to actually be my new x-axis. So this is the same. So if we consider this point here is at 0, -1, it's going to go to the point of 0, 2. So it'll be 2 above now the x-axis. So I can see from here, if I lifted this graph or translated it up by 3 units, this would become where the x-axis was, and we could see we have 2 solutions now. And I'd even be tempted to show the examiner. So 2 solutions. Okay, next one, in part D, we need to write down the number of solutions to the equation 2f of x is equal to -6. So if we consider what we're going to have, our point now stretched by 2 in the y direction. So we're going to multiply all of the coordinates now by 2. So if we think at this point right here, this is where now x is equal to -3. So all of the points below this would be past -6. So yet again, what we're going to have are 2 solutions. So 2 solutions now to the equation 2f of x is equal to -6. Let's say this point now was negative, the y coordinate was negative 4.5. That would go out to negative 9. These points right here, if we put a scale factor stretch on, would go out to negative 6. Negative 6. Anything below this particular line would pass the line. Now y is equal to negative 6. Therefore, we can see it crosses twice. 2 solutions. Okay, let's move on and look at another question. In question 2, we're told f of x is the quantity 2x minus 1 all squared minus 4. So this is a quadratic equation. In part A, we're asked to sketch the graph of y equals f of x, stating the coordinates of the point where the curve crosses the coordinate axis. I think that should be the points where the curve crosses the coordinate axis, and the coordinates of the minimum point. So this is already now in completed square form. When we have a quadratic in completed square form, we can get now the vertex, or if you like, the minimum point. So let's go ahead and draw this up. So what we're going to have then is this positive quadratic, so it's a positive parabola, and we're going to have now the minimum point. So just here we're going to have, so 2x minus 1 is going to give me x is equal to 1/2, and then we're going to have now the y coordinate of negative 4. So what we'll have is this point right here, and that is going to be 1/2 comma negative 4. What we need to consider is where this is going to cross the x and the y axis. If we consider now setting x equal to 0, that's where it's going to cross the y-axis. So 0, that's going to leave me negative 1. Negative 1 squared is 1. Subtract 4. We're going to get this point right here. And that point is going to be 0, comma negative 3. What we now need to consider is where it's going to cross the x-axis. And that is where y is equal to 0. So what we can say from this point right now is that 0 is equal to the quantity 2x minus 1 all squared minus 4. Adding 4 to both sides, we've got 2x minus 1 all squared, square root in both sides, plus or minus the square root of 4, that's going to give me plus or minus 2, is equal to 2x minus 1. So if we just consider this, let's do now the positive. 2 is equal to 2x minus 1, and we can see that x is going to be 3 over 2. If we solve for the negative 2, we've got negative 2 is equal to 2x minus 1. So we've got negative 1 is equal to 2x, and we can see now that x is going to be equal to negative 1/2. So if we put that just there, that's going to be negative 1/2 comma 0, and then we're going to have this point just here, which is going to be positive 3 over 2 comma 0. So we have those points, we can draw our parabola. Our parabola looks something like so. So let's just go ahead and do that, and that's what we've got. So just make that point slightly tidier, but we've got all of the information that we've been asked for. Okay, so that's what we got. In part B, it says sketch the graphs of the following curves stating the coordinates of the maximum or minimum point. So what this one is now, the first one is y is equal to negative f of x, and then we're going to have plus 1. So we've seen this plenty of times in the previous video. It's a reflection in the x-axis and then a translation of 1 unit in the positive y direction. So if we consider now, if I reflected this in the x-axis, we would have now the point 1/2 4. This point would go to positive 4. Then I'm just going to add 1, and that's going to give me now that the maximum point from, remember this is a minimum point right here, the maximum is going to be 1/2, and then we're going to have positive 5. So let's go ahead and draw that. I'm simply reflecting it in the x-axis, and then I'm going to lift it up by 1 unit. We're not asked where this crosses any of the coordinate axis, we just have to go ahead and draw this. So what I'm going to do is just now draw this in a quick sketch, and we'll have something that looks like this. So there's no alteration in the shape, and I'm just going to put that this point right here, we're going to have on here now 1/2, and then we're going to have now comma positive 5, and that one is done. Okay, let's look at the next one. We've got f of x minus 2 plus 1. So this is just now a translation in both the x and the y direction. So what we're going to have is 2 in the positive x and 1 in the positive y. So just consider we're going to move this now 2 to the right, and then we're going to move it 1 up. If I go ahead and do that, again, no alteration in the shape. I'm just going to draw it here. We're going to have this point now. So 1/2 plus 2 is going to give me 2.5, or 5 over 2. And then I'm going to have, and I'll put it just here, we're going to have 5 over 2. And then instead of -4, I'm going to be adding 1. So that's going to go to -3. No alteration in the shape. And all I'm going to do is just simply go ahead now and redraw this. In terms of the accuracy, I'm not going to spend a massive amount of time making it look accurate. So let's just go ahead and draw a sketch of this, and it's going to look something like so. So no alteration in the shape, and that's what we'll have. So let's just label these up. Y is equal to 1 minus f of x, and then this one is going to be y is equal to f of x minus 2 plus 1. Okay, let's now look at this one. We got 3f of negative x. So with this one, we're going to have a scale factor stretch of 3 in the positive y direction, and we're going to reflect this in the y-axis. So if we consider, if I reflect this in the y-axis, that's going to be -1/2, and then we're going to have -4, and then we're going to multiply this coordinate by 3. So we're going to have now -1/2, and then we'll have -12. So this one right here is going to give us -1/2, comma, -12. So that is going to give me now the minimum point. So let's go ahead, and remember, this is a sketch. We're not plotting it. It doesn't have to be insanely accurate. It just has to be a good representation. So what we're going to have is have this point down here, and let's go ahead and do this. This is going to be now, and we'll put it there, -1/2, comma, -12. And I'm going to try and emphasize now a scale factor stretch of 3, so it looks something like so. Not brilliant, but it just gives you some idea. So y is going to be equal to 3f of -x. We've put now the minimum or the maximum points on here, and that is done. Okay, so that's 3f of -x. Let's just check that. Reflected in the y-axis and scale factor stretch of 3 in the y direction. In part C, it says the equation f of x plus k equals 0 has equal roots. We're asked to state the value of k. If we just consider, if this has equal roots, we could either look at the discriminant now being equal to 0, or we could just consider that if we lifted this up, and let's just write this here. If I made now this distance right here, well, we can see that's 4. If we say that k is equal to 4, we have now f of x is equal to 2x minus 1 all squared, which is going to touch the x-axis at the point where x is equal to 1/2. We'll have 1/2, 0. So you don't need the discriminant on that one. All you need to do is consider that this graph has been moved up by 4 units such that it touches the x-axis. So all we need is a vertical translation, and we need k to be 4. So 2 exam style questions on curve sketching.